All right. Computing limits analytically, graphically, and numerically. So, one way to compute a limit is analytically. If we are given the limit as x approaches 3 of x squared plus 2, this will simply be equal to, if we plug in 3 for x, so this will be equal to 3 squared plus 2, which is equal to 9 plus 2, which is equal to 11. Now, typically, a lot of the time, we can simply just plug a limit into an equation like this, and it works out. But in some cases, for example, the limit as x approaches 4 of x squared minus 16 over x minus 4, if we were to plug in 4 as our limit, it would be equal to 16 minus 16 over 4 minus 4, equaling 0 over 0, which is undefined. Now, a lot of times, when given an equation like this, and if we get 0 over 0 for our limit, we can try to simplify this equation. So we know that the factors of x squared minus 16 are x minus 4 and x plus 4. So, and this will be over x minus 4, and this will equal, this means that this is also equal to the limit as x approaches 4 of, crossing these out, x plus 4. Now, this equation is a lot easier to plug into, because it is simply equal to 4 plus 4, or 8. So that is one way to compute a limit, and two different ways for that way. Now, the next way we can compute a limit is graphically. Now, when computing a limit graphically, we simply just make a graph or use a graph provided to find the limit. So, for example, if we are given our previous limit of x squared, or the limit as x approaches 3 of x squared plus 2, if we were to compute this graphically, we would simply just create a graph. Now this is mostly gonna, or almost all, gonna take place on the positive side of the y-axis. Alright, so plus 2, so start right here. 1, 2, 3, there, and that should continue up. 1, 2, 3, 4, 5. That's 5 up there. And I'm not gonna continue it on this side since we're running out of space, but pretty much it's going to be the same off on that side. But right now what we're concerned of is what this value approaches as x approaches 3. Well, simply all we need to do is just look at 3 and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means that the limit as x squared plus 2 of x approaches 3 is going to be equal to 11. And finally, computing limits numerically. So say we're given the limit as x approaches 2 of sine of x. Well, when you compute a limit numerically, you set up a table of values. So let's set up 1.9, 1.99, this should be x, should be our y, 1.999, then you have 2, then you have 2.001, 2.01, 2.1 finally. Now, you just plug in the values. So 0.9463, then 0.9143, then 0.9097. Now we move over here, 0.9089, and then 0.9051, and then 0.8632. Now, if you notice, in between here, these numbers start to get very close to a certain value for 2. This value is 0.9093. It's directly in between 0.9097 and 0.9089. Now, since this is our value for 2, this means that the limit of sine of x as x approaches 2 is equal to 0.9093.